Okay, hello, good day, grade 12. So, welcome to our second lecture for General Physics 1, which is all about vectors. The learning competencies to be discussed for this lecture are the following. Okay, so before we start with our main topic, let us recall what we have discussed on our previous lesson. So we have known that in measurements, in order for us to represent a specific measurement properly, we use quantities. Okay, physical quantities are the numerical representation or description of how many or how much a specific particle is depending on its physical categories. Okay, so we have physical quantities and derived quantities. So derived quantities are from derived equation and derived formulas. Okay? So to further categorize, okay, a specific quantity of a measurement, okay? So we use, okay, scalar and vector. So what is the difference between scalar and vector? Okay, so we know that a scalar quantity or a quantity is considered to be scalar if it expresses magnitude only. Okay, so what do we mean by magnitude? Magnitude tells just simply tells us how many, okay, that specific quantity is. Okay, this is the numerical description of a quantity. Okay, for example, okay, it is speed, volume, mass, temperature, and power. Okay, as well as time. Okay, on the other hand, we have vector quantity. Okay, a vector quantity, unlike a scalar quantity, okay, it expresses both magnitude and direction. Okay, so quantities under vectors are velocity. Okay, why velocity? Because velocity is speed of an object in motion with a specific direction involved. Okay, so for example, if a quantity or okay, if a specific quantity, for example 5 meters per second, okay, is expressed as just like this, and the other one is 5 meters per second to the right, okay, the first quantity is considered to be scalar and it is speed. Okay, on the other hand, this is a vector and it is now called velocity. So we can conclude based on this, okay, representation that velocity is, okay, speed plus direction. Okay, the direction here is the representation of our arrow, which means this arrow means that our body is going to the right. Okay, so it has both magnitude. Magnitude is the numerical or the number on the quantity, and the direction is the arrow. Okay, so to further classify which quantities belong to vector and scalar, you can refer to this table. Okay, so but on this lecture, we would be more focusing on vectors and how vectors are represented on different calculations. Okay, so representation of a vector. Vector are represented by drawing arrows. Okay, the length represent the magnitude and the arrowhead indicates the direction. Okay, so if the length of an arrow is small or longer, so it means it has either a smaller magnitude or a bigger magnitude because the length represents the magnitude while the arrowhead represents the direction. Okay, so if Also, to numerically represent the direction of a vector, we ginagamit po natin yung Cartesian plane or the angle, okay? The angle relative, okay? Angle theta, okay? Relative to x axis. Okay, what do we mean by relative x to x axis? For example, we have here this vector quantity. Okay, so vector unit. In order for us to numerically define or describe its direction, we have to know, okay, the angle, okay, of inclination of that specific vector with respect to our positive x-axis. So, for example, this is theta x is equals to 45 degrees. So, meaning this vector r or vector v is equal to 15 meters per second. Okay? So, ang pwedeng representation natin ng vector dyan, numerically, is 15 meters per second angle 45 degrees. So, pwede din gamitin natin dyan is yung with the use of the compass, south, east, northeast, northwest, okay? But, for us to be more familiar with the angles and the trigonometric function, so we use theta, okay? So, vectors can be added geometrically, okay, by placing the tail of one vector on the head of the another. The resultant vector is the vector that begins at the tail of the first vector and ends at the arrowhead of the final vector. So, to fully imagine this statement, okay, so, for example, we have two vectors. This is vector A. Okay, we need to add it to, okay, vector B. So, to geometrically add this one, so we have to first draw, okay, this is vector A. So, according to this statement, pag mag-a-add ka daw ng vector B, susundan mo lang yung arrowhead niya, okay, and then, i-write mo na or i-draw mo na si vector B. So, end-to-end po tayo. So, kung ano yung end ni vector A, which is its arrowhead, so, lalagay mo yung tail ni vector B, tapos, i-draw mo na yung direction ni vector B. So, para naman makuha natin yung resultant, okay, resultant vector, so, ang tawag natin sa sum, okay, sa sum ng ating resultant, sa sum ng ating dalawang vectors is the resultant vector. Okay, so kukunin mo yung tail ni vector A. Okay, doon ka magsa-start and then iti-trace mo hanggang ma-reach mo or ma-connect mo yung arrowhead ni resultant vector kay vector B. So, resultant vector C. So, ito yung magiging sum nila pagka inad mo na yung dalawang vectors geometrically. Okay? So, vectors can also be subtracted by adding negative vector. Okay? For example, let's use the same diagrams. Okay? So, this is vector A. We need to subtract, okay? We need to subtract it from our vector B in order for us to get C. So, paano natin to gagawin? Ano yung meaning ng subtraction dito? Okay, so normally kasi, ang vectors can only be added, okay, not subtracted. But how can we, okay, geometrically represent this kind of phenomenon or situation? Since yung subtraction dito is parang negative siya, so kailangan mong i-negate yung value, okay, or yung vector na yon. So sulat muna natin si A. This is A. Okay? How about B? So, kung ininegate natin siya, papalitan lang po natin yung direction. Pero yung magnitude ay same pa din. Okay? So, kapag ininegate natin siya. So, kung papunta siya dito, vector B would supposedly going to this away. Okay? So, opposite. So, opposite nitong vector B. But, please do imagine na same yung length nila. Supposedly, dapat same yung length. And then, apply ulit natin yung rule from A, okay, to B. This is our resultant vector C. Okay, so that is how to represent addition of vectors geometrically. Okay, so in vectors, maano natin dito, okay, may encounter natin yung component system. Okay, method of components. Simple but general methods for adding vectors. Okay, so vectors is not limited to purely horizontal and purely, okay, vertical. So, meron tayong mga may encounter na vectors that are inclined at a specific angle. Okay? So, for example, balikan natin to. So, yung resultant vector natin, sabi natin, papunta dito. Okay? So, paano natin madidistinguish yung components of yan, vector C? Okay? So, yung components na tinatawag natin dyan, or yung pinapertain nating components of a vector is its x and y. Okay? X and y components. So, kung ito, okay, kung ito yung ating vector, if we're going to find its component system, okay, we have to know its y component as well as its x component. So, how do we do that? Okay, for example, let's give a value to this vector. Okay, vector C is equals to 15 newtons angle 30 degrees. Okay? So, paano mo kukunin yung component CX or component ni vector C sa x-axis at component ni vector C sa y-axis? So, gagamit ka ng trigonometric functions. Okay? Specifically, SOHCAHTOA. Okay? So, kung i-arrange mo yan in the form of a triangle, and then ipaprocess mo yan gamit ang SOHCAHTOA, para makuha mo yung CX, okay, lalabas dyan yung equation na C cosine theta. Okay? So, bigay ko na lang sa inyo ito para hindi na kayo mahirapang mag-derive. So, this is always applicable in finding the x component. Kahit anong direction yan. Okay? Ito yung equation. For cy naman, C sine theta. Okay? So, paano po ito kino-compute? Let's start with the x. So, laging tatandaan, kapag x component ang hinahanap, okay, kapag x component ang hinahanap, ang gagamitin ay cos. Kapag y component, sine. So, you have to get the magnitude, which is 15 newtons Newton. Cosine, the theta here is this one. Okay, 30 degrees. So, Cx is equal to 15 cosine 30 okay, is equals to 12.9904 okay, newtons. Kasi newtons yung unit. Okay? Next, kapag CY naman, so same method, 15 sine 30. Okay, CY is equals to 7.5 Newton. So that is how we get the components of a vector or a resultant vector. So what if it is the other way around? What if we're given, okay, what if we're given components x and y and we have to find c? So how do we do that? We use naman Pythagorean, okay, Pythagorean theorem, whereas A or resultant vector RV is equals to component niya sa x squared plus component niya sa y squared, square root of that expression. Okay? So if we're going to find C, it is square root of cx squared plus cy squared. C is equals to 12.9904 squared plus 7.5 squared. So it is equal to okay, approximately equal sa 15 newtons. Okay? So this is Pythagorean theorem is only used for finding the magnitude of the vector. Okay? So, since we're talking about vector, we also need to find its um, direction. Okay? Finding their direction by finding the um, angle. Okay? So, if we're going to plot this, okay, on the horizontal or on the Cartesian plane, okay, ang makukuha natin dyan is ito yung y, diba? Ito yung y, ito si cy, kasi positive siya, positive 7.5. Tapos, ito si cx. Okay, sorry. Kasi positive din. So, si c, okay, supposedly, dapat pala ito ay end-to-end. So, we have to strictly follow the technique. Okay, let me redraw. Okay, so ito si cx. Draw with touch. Okay, so we have to strictly follow cx and then we have cy. Okay, so kung ipa-follow natin yung rule natin kanina in graphical representation. So c would be towards this direction. Okay, resultant c. So, yung resultant c natin using Pythagorean theorem equals sa 15 Newton. So, kailangan pa nating hanapin itong angle na ito. Okay? So, how do we do that using the right triangle rule and the SOHCAHTOA? Okay? So, SOHCAHTOA. Okay? So, since ito po, ang hinahanap natin ay meron tayong opposite. The CX is our opposite face of our right triangle, and CY is our adjacent face. Okay? So, ang hinahanap natin is this angle. So, we could use, okay, TOA. Okay, TOA expression. So, in TOA expression, equal po siya sa tangent theta, okay, equal sa AY over AX. Or, if ever, since we're going to find theta, so theta is equals to arctan AY over AX. So, AY is the adjacent and then AX is the opposite. Okay? So, theta, angle theta, is equals to tangent negative 1. Okay? Hanapin na natin yung sa C, CY over CX. Okay? Equal sa tangent negative 1, 7.5 over 12.9904. Okay? So, angle theta would be equal to approximately 30 degrees. Okay, so that's how we get the x and y component as well as resultant vector magnitude and direction. Okay, so to furthermore elaborate SOHCAHTOA, okay, so we could use this diagram. Okay, so kapag meron tayong right, okay, pag meron tayong right triangle, so yung angle, lalagay yung ilolocate yung 90 degree arm. Okay, kung nasan yung 90 degrees. Tapos yung sa taas ng 90 degrees, yung vertical axis nun would be always the opposite, and then yung horizontal is yung adjacent. Then yung inclined, okay, is the hypotenuse. So, and then the adjacent corner, okay, with respect to the, okay, right angle arms, okay, is the theta x. Okay, so sine x, if we're going to use, or when we're only given of the opposite and hypotenuse, we could use SO. Okay, opposite over hypotenuse. Kapag ka naman adjacent hypotenuse, cosine. Kapag ka naman opposite adjacent is tangent. But I do, okay, lagi kong ginagamit is tangent. Okay, for me it's much simpler to um, analyze, okay, objects that are, okay, in the x and y, okay, axis. Sorry, should be baliktad. The y and x axis. Okay, so let us try answering this problems. Okay, an Air New Guinea airplane is traveling east at a velocity of 115 kilometers per hour. The wind blows east at 20 kilometers per hour. The resultant can be found by drawing two vectors at the same scale and adding head to tail. Okay, so since both the air or the airplane and the wind, okay, is going to the east, that's why we add them up. So, same direction lang sila. Okay, so 115 plus 20 is equals to 135 kilometers per hour, which is the resultant velocity of plane moving to the east, since both of our vectors is of the same direction. Okay, second example, the velocity of an airplane is 125 kilometers per hour and its course is eastward. Okay. In this example, nasa opposite direction naman yung ating wind, which blows towards west at 25 kilometers per hour. The head wind will slow the plane down. Okay, so it is due to air resistance. The resultant velocity of the airplane is found by adding the vectors head to tail again. So head to tail, and the resultant velocity of the airplane will be 100 kilometers per hour east. Okay? So, i-ano pa rin natin, gawin pa rin natin yung head to tail, but i-oppose lang yung direction since opposite yung direction nung wind velocity. So, we have to subtract 125 to 25. So, the resultant velocity of the plane to the east direction since it has the greater velocity. So, yung susundin natin lagi is yung direction with greater, okay, greater magnitude. Okay? So, for example, katulad nito, mas malaki si 125 in comparison to 25. So, that's why hindi mapipigilan ng wind, ay hindi matutulak ni wind si airplane pabalik or backward. So, ang tendency, mariresist, okay, mariresist ni airplane yung wind. That's why it is still going eastward. Okay? Okay, last example. We have here our components plotted on the Cartesian plane. So we have x component which is equals to 20 units and then y component which is equals to 20 units. We have to find resultant vector v and theta. Okay? So, gagamit tayo dito since resultant yung hinahanap natin. Resultant v. Okay? So, v is equals to vx squared plus vy squared using Pythagorean theorem. Okay? So, square root of 20 squared plus 20 squared. So, resultant v is equal to 20 square root of 2 or 28.2843 units. Okay, so hindi tayo titigil dito ha. We have to, since we're talking about vector, kailangan may direction. So, kailangan nating hanapin yung angle theta using SOHCAHTOA. Okay? Or, for this example, yung tangent negative kasi given na tayo ng x and y or the opposite and adjacent. So, tangent negative 1 vy over vx. Okay? So, angle theta, tangent negative 1, 20 over 20. So, angle theta, tangent negative 1, 1 is, would be the final answer. Lagyan na natin. 45 degrees. So, resultant vector v is equals to 20 square root of 2 units angle 45 degrees. Okay? So, that is for x and y component that is positive or both on the positive axis. Okay? So, madaling isolve kapag ganon. So, what if nandito na, okay? What if nandito na yung v mo? Okay? So, nagbago yung direction ng v mo towards this part. Paano mo i-compute yung angle? Okay? Angle reference to x-axis. So, meron tayong rule na ginagamit dito or meron akong strategy na ginagamit dito. Okay? So, if you're going to look on your So you're going to look on your x and y components or in which quadrant it is on the Cartesian plane. So alam natin ito yung quadrant 1, quadrant 2, sorry, quadrant 3, and this is quadrant 4. Okay? Kapag ka nasa positive pareho, okay, yung x and y component natin, siya ay nasa quadrant 1. So, yung calculated natin, so yung na-calculate mong gamit yung SOHCAHTOA, okay, or TOA, okay, specifically, yun na yung angle reference to x-axis. Okay? Kapag ka naman nasa quadrant 2 siya, whereas your x component is negative, meron kang positive, okay, y component, nasa quadrant 2 siya, yung para makuha mo yung angle reference to x-axis, you have to subtract your calculated, okay? So, kailangan mong i-subtract yung calculated theta mo kay 180. Bakit? Kasi, so, ito yan. So, ito yung mako-compute mo dyan. Okay? This part yung mako-compute mo. And, para makuha mo yung, kasi kailangan natin reference to x-axis, diba? So, reference to x-axis, we have to subtract our calculated to 180. Okay? So, same goes with quarter 3 and 4. Okay? So, kapag ka both negative sila, nga sa quadrant 3 yung vector mo, para makuha mo yung reference to x-axis, i-add mo siya kay 180. Kasi ito yung mako-compute mo naman dyan. Yan. Okay? Kapag ka naman positive ang x-axis mo, negative ang y-axis mo, and nasa Q4 ka, para makalculate mo yung reference to x-axis, i-add mo siya sa, ma-minus mo sa 360. Nasa quadrant 4 na nga pala tayo. So, 360 minus calculated theta. So, further on our exercises discussion, we would be utilizing this rule. So, please take note of this. So, for now, kindly go on your learning materials, with all your materials, your lectures. We will be having a graded recitation. So, if ever you have queries, questions, don't hesitate to reach out through me. So, that would be all for this lecture. Goodbye and thank you.